let us then begin with the questions that were given last time, and maybe from last time also some questions are. But let's begin with the questions from last time itself. So, yeah. Please, someone just tell me the questions. So it was related to arithmetic progressions, right? Yeah. Anyone? None. You can tell.
Yeah, one of the problems was a7 plus a7 minus 1 plus a7 minus 2 plus a7 minus 3 is equal to 0. And you've given that a sub 1 is equal to 1, a sub 2 is equal to 2, and a sub 3 is equal to 3.
Right. N minus 1, n minus 2, till n minus 3. Correct. Is equal to 0. And what was given?
A sub 1 is equal to 1, a sub 2 is equal to 2, and a sub 3 is equal to 3.
Right. And you wanted to find a of something, maybe a of 100.
Yeah, find a sub 100.
Right. So anyone when it's possible to do this?
I tried few values. I wasn't able to solve it, but one was you can try with a sub 4. And you've given that the values of a sub 1, a sub 2, and a sub 3. So a sub 4 is equal to -6.
Right. Yeah.
And you can do the same for a sub 5 and you get 1. So, so yeah, one thing. So I guess is that a sub 100 is equal to negative of a sub 99 plus a sub 98 plus a sub 97. That's the pattern of derived.
Yeah, that is certainly correct. It means that is from the definition. A of 100 is equal to negative of. But then are you saying anything more?
Oh no, that's all I've tried so far.
Okay. And Nagesh, did you do this question? Were you able to do this question? Right. No, okay. So we'll do it now. Okay. So seems like none of us have been able to do this. So let's try. I also don't know the answer. Let us try to see something. We did a simpler version of this question, right? And even if I go to a more simpler, maybe the trivial version of this question, let's say that I tell you that this is equal to 0. Okay? And let's say also a1 is equal to 1. Find a of 100. This is about who can tell me the first, because this is like, I think, easy. Very, very. So we're doing this one, okay? Just this. This one is very easy.
Minus 1, is it?
Yes, -1. Why others are not?
Yeah,
cannot get Nandini, have you got this -1?
Yes, sir.
Right. And it just oscillates. There's nothing to do, right? So simple. Okay. So this one is just an oscillating sequence in the sense that it is like maybe now you can try to relate a bit. If you just try now to relate it with this question. Okay. So there are no ideas. Then we will take it one step further. Let's do this one. This question we did at one point earlier. So
Is it 1?
Is 101?
Yeah.
I don't know the answer. Why is it 1? Let's see. What's your explanation? There may be some very good explanation. I don't know. I just made this question up, but I don't know the answer. So why?
No, because A6 is 2.
A6 is 2. Okay.
So I thought it would be just cyclical. A7 would be 3 and
So compute it. Let's compute it. You compute A7. Is it A7 will, I think it will not be A3. But computing will always be useful, at least later maybe. Is it coming out to be 3? I mean, it's
yeah.
right. Yes, it is indeed coming out. So let me just step back and think why I was thinking that it would never come out with. There was something conceptually wrong. Fine. So I was thinking something very wrong, computationally wrong. So now is it all good? Is it all set?
Yeah, A8 is 6 minus 6.
8 is minus
So
6. Yes. Okay. So Nagesh, maybe you add a few more details to explain it like more clearly why this pattern will continue or so on.
so this is repeating for every 4
Every 4.
numbers, right? So for 100, yes.
But please explain maybe why it will continue to repeat. Maybe that's not very needed, but still, if you why this repetition will continue. I can understand it's almost obvious, but let's think about it mathematically more.
Sir, it's because it comes back to the same number, right? It comes back to 3, so it must go. The pattern must repeat again.
Yes. Okay. Yeah. Okay. So maybe I would just add that. Yes, Nagesh. Yeah. So Satya has not said yes. Has not said anything wrong. Satya has not said anything wrong, but I would say it's little incomplete. So fine. Okay. So
Is it because the fourth term is sum of the previous 3 terms?
Yeah. So the reason is sum is fine, but the reason can be, so you can explain it without relying so much on the sum by relying on less things. So well, you can just say that the nth term depends on the previous 3 terms, right? So if the previous 3 terms match, then the fourth term will also match. Right? So the reason is that it's the recurrence. Yeah, it is the recurrence, right? So we have these first 4 terms you can calculate. Let me say, so if you do till here, right, then we cannot be sure that you will get 3 next. Do you get the point, right? Till here, you cannot know that you will get the 3 next. Okay. But once you get this 3, then this 6 depends on the previous 3 terms, right? So this one has to come out to be 6. Okay. So whenever you have a 1, 2, 3, then the next term has to be 6 because of the recurrence, not necessarily sum. It could be any relation. The point is that the fourth one, it depends, so the term depends on the previous 3 terms in the same way. That relation doesn't change no matter what the n is. I have also not given a very clear explanation, but yeah, just a second. Right. So maybe this is the homework here, and try to do this. Means do try this. Okay. Prove this by induction. What do you have to prove? You have to prove that, for example, a of 4k is equal to minus 6 for all k. You know it is true, but mathematically we have not proved anything. Meaning that what we have said, for instance, the computer will not understand. Something like this we want to say, right? And maybe we also want to say like a of 4k plus 1 means the 4k, any term which is like a1, a5, a9, all those, they are all going to be 1 for any k. And similarly, you can write, but do this as an induction exercise. The only way to prove it, clearly prove it, is by induction. Otherwise, all of the proofs are just convincing. Okay. But you understand that this is the nature of recurrences. Once you see a pattern, and if it's long enough, you know what long enough will mean in the context, it will repeat. So the problem is done. It's very, very simple. So anyone, what's the moral of the story? Nothing. It is just that you have to calculate more terms, nothing more. You don't need any insight from before to do this question. Okay, maybe you needed to make the question, maybe, but otherwise you don't need to do the question. Okay, just calculate enough terms, and if you don't do that, then you have missed the question. Sorry. All right. So any questions so far? You see, one interesting thing has happened. We looked at this sequence. I mean, the sequence which was generated by this kind of recurrence, the sequence that was gotten by following this rule, and this kind of sequence, they are all periodic. Sorry. Right? All these sequences periodic. Okay. Whereas if you look at this sequence, the Fibonacci sequence, this was far from periodic. This was not periodic, right? It was growing and growing. Okay. So there is something interesting, right? So maybe you can now try this for homework. So the fact that this is periodic is not a problem, but also the period also seems to be interesting, right? So in this case, the period was 6, right? I think something like that. It was repeating after 6 terms. I mean, I was expecting it to repeat after 3 terms, but somehow it was repeating after 6 terms. Oh, no, I think it was not this question, right? Yeah, it was not this question. This one would. So can you just quickly do this? Let's say A1 is 1 and right, and A2 is 2. Did you just do the second question? Anyone? I mean, this one? It's all of you obviously have to do. Sorry, I'll just come just in a minute. Just try this one. It's also easy. So that is also just repeating, right?
Yeah.
So A3 is, but are others also getting it on
Minus
their
3.
own? Yeah, -3. And then
Okay,
what
what
is it?
to minus 3?
Okay. There's nothing to do, right? But now it would be interesting to explain why this is happening. So this is 1, 2, -3, 1, 2, -3. Very clear pattern. This has periodicity 2. This has periodicity 3. This has periodicity 4. And you can see there are 4 terms, sort of. Right? Find an explanation for the following. Don't get don't get afraid of, I mean, you will not, but yeah. The variable. Let's say that it depends on the last. It's up to you. If you can just want to do for n-4, you can do. n-5, you can do. But maybe if you can explain it conceptually. I'm giving a big number so that you have to explain it conceptually. Okay. But otherwise, you can take small number and do the same exercise again and again. Not again and again. It will be slightly harder every time. Maybe -20. Okay. You can start with just 1 to 20. That actually doesn't matter. You understand that. Yeah. Explain the periodicity. You will see that the period will be 20. Explain the periodicity. Now, how do you do it? That's up to you. You may look at this and explain the periodicity of this in a different way. It's up to you. Okay. See. Try. Just try. Okay. Do I want to say anything more? Yeah. No. So we'll say later. Later on, we will have enough numbers in our number system. When I formally do complex numbers, then we will be able to explain all these patterns. Okay? Means that in a different way. Right now, also you can explain. Okay. So now let's move on to the next question. So what was the other question? There were more questions, right? 2, 3 questions were there.
If A1, A2, A3, B3, APs.
If A1, A2, A3,
B3 APs.
Oh, like that. 3 APs. Yeah. Okay. A1.
Yeah.
Okay.
And if A1 and A2 have a common term.
Okay.
And A2 and A3 have a common term. Will A1 and A3 have a common term?
Right. Will A1 and A3 have a common term? So this just means the intersection, right? Intersection of the two sequences. Is there something in common? That, but you can just read it as you have in your question. You can read this, you can read that. It doesn't matter.
Sir, what does that symbol mean?
So this is like intersection, right? So this like there's not a concrete notation, okay? But it's just our interpretation. Natural interpretation is what, like this is an arithmetic progression. So it's a sequence of numbers, right? A2 is also a sequence of numbers. This intersection means that there is something in common between them, meaning that the intersection is not empty. This phi means empty, right? And similarly, this means that it's not empty. And then the question is, does it imply that this is also not? The first and the third also have a term in common. Okay. But
Yeah, okay.
yeah, it's not necessary to interpret this notation too carefully. You can use the thing. So what do you think the answer should be? Is it so you see the second arithmetic progression intersects with the first and the third, right? That's what we are getting. That you have this arith AP, right? First one. Now you can start writing it in this way if you want to. And then there is a second one. And then there is a third one. So these two have something in common. These two have something in common. And the question is, will the first and the third also have something in common? So this is actually, with the solution is going to be very, very short. And but I just want to, if you have tried some examples or something. So the first and second have some terms in common, and hence they have infinitely many terms in common that we have shown last time. Right? Similarly, second and the third also. But what about the first and the third? Any guesses? What do you think? Do you think it will be true? Not true.
No, I'm guessing it would be true.
Would be true. Oh, okay.
I don't know. Maybe I think we can like prove this by using some kind of system of equations using the arithmetic
Right.
progression formula.
Right. Let's try that. Yes. So I think your answer is correct in the important case. So there is a very, very important situation in which it is true. But in general, if it's true or not, let's try your approach. So first and the second one have something in common, right? So we can say like A1 plus, just using the very, very standard notation. Okay, not changing anything so that there's no notation problem. This thing is in common. So the nth term of the first one is equal to the some other mth term. I have to introduce a new m, right? Some different term and some different common difference. Don't be afraid of this notation. These are just numbers. It's just that we don't know them. They're not these arbitrary numbers. So then also we have the second and the third one have something in common. So this will not be m, right? It will be something else. We don't know. Something else. Again, common with something else. So again, something is wrong, right? It will be D2. And this will be D3. Does this imply that the first and third should have something in common? So this is like a number x, and this is like some number y.
Do we actually need the second sequence, like B1, B2, B3? We can just say that A1 and A1, the first sequence and the third sequence will have something in common, right?
Oh, that we have to, yeah. So why is that? That we have want to prove or we want to disprove? We want to show.
No, we just prove that last time, right? Like if you take any two sequences, they'll have a common term. Why can't we just take the first sequence and the third sequence and
No,
give the
no,
same proof?
no. We did not prove that. We did not prove that. Like you take like 1, 3, 5, all odd numbers and a sequence of all even numbers. Right? That's not correct. Even intuitively you can think, right? If two numbers, you can think there's nothing, they won't have common. We proved that if they have something in common, then they have more things in common. Everybody,
Okay, yeah.
right? You can, yeah. For instance, if you take two arithmetic progressions that start at different places, but they have the same common difference, then they will never meet. Right? They will keep having the same difference. Okay. So that is, but that's the interesting statement, right? If they have something in common, then they have more things in common. It was easy to prove, but yeah. See, this equation looks pretty lost, right? I don't know. You may get pretty strange what to do, right? Yeah. There are many ways to do this kind of questions. Some more number theoretic flavor. This is actually a number theory question in the form of arithmetic question. Okay, I mean, let me see. I mean, if you consider the first as, let's say, odd numbers, right? And you consider maybe the last one as even numbers. Let's say this is a hint. Simplest arithmetic sequences. I'm not able to say this is a better way. I think that would need some number theory, just the language of some divisibility and so on, which I don't want to bring. I mean, you guys know it, but I don't want to confuse it with these two things together. For now, can you give me a B which intersects with both? What B will intersect with both? Some B, any B. Any arithmetic progression here that will work for both? In a sense that will have common with the first one, odd numbers, and also with even numbers.
Bro, what about just like a straight consecutive sequence? 1, 2, 3, 4, 5, 6, 7, 8.
Yes,
I'll have common.
absolutely. So then you got the answer, right? The answer is no. So you have just merged the sequences like this, right? So when you merge two arithmetic progressions in an easy way, easy way, if you merge it, meaning alternately at least, then you get an arithmetic sequence. That is always true. Can everybody feel that? Right? Yeah, write it right. But this is clear. So the answer is no, and it's like a rather silly question in that. But yeah, there are still a lot of things about arithmetic progressions that one has to feel and like, get on an intuitive level also. Just equations and all will not always, at least till we have the correct language of matrices and so on. It's difficult. Okay, so the answer is no. Is it clear? It's right in front of you. Odd numbers, the second sequence and third sequence. Not first and third have nothing in common. Okay. Let me first connect this with two things that is there. First, I would like to show a little bit of a number theoretic side to it, just a little bit, so you can get thinking on that. Okay. And also, this merging of two arithmetic sequences is also a very interesting question. So let's look at both of them. So first, let's look at the merging thing, since I think that is easier. Merging two keys. So how do you do this? So you just okay. Let's say that this is an AP and this is an AP. Okay, these two are AP. I'm not writing A1 plus D1 and so on. Okay, two APs like this. Then will this also be an AP? Okay. The question is clear, right? Those two APs are those APs, and then the question is this an AP? Yeah, I mean, maybe it is not. Maybe what I said is not correct. Okay, so less than 1 minute is left, so you have to join again. Okay. Think about this. Yeah, certainly not. Wrong. Yeah. So what I said initially was incorrect. Merging two AP is not always an AP. In that case, I mean, it's obviously not. How did I even say it? End of the meeting.